Hello everybody, welcome to Conf42 Kube 2024.
Hello everyone, we are thrilled to be here to talk about KubeVirt and how it brings virtualization into the Kubernetes world. This is our first talk at Conf42 and we are super excited about that. Hope it won't be our last talk.
Today we'll dive deep into how you can leverage KubeVirt to run virtual machines alongside your containers, giving you a unified platform for managing both of them. By the end of the session, you'll know how to get started with KubeVirt and integrate it into your Kubernetes environment. But first, let's introduce ourselves, Batuhan.
Hello again. My name is Batuhan and I am working as a platform engineer here at Trendyol. For those interested in software supply chain security, you might know me as one of the early contributors of SixStore, for which I was selected as Best SixStore Evangelist at 2022. I am proud to be very first astronaut from Turkey. I am also CNCF ambassador and Docker captain and one of the organizers of K8s Istanbul.
And my name is Koray. I work as a Kubernetes consultant and technical trainer for Kubematic. I am also CNCF ambassador and Kube astronaut. I also contribute to the Kubernetes project on K8s infra. To start with, Batuhan, you're a platform engineer, and I know that you worked on a few migration projects from virtual machines towards containers. Let's start by looking at the fundamental difference between containers and virtual machines.
Yeah, sounds great, Koray. People might know that containers are lightweight, right? Designed to run isolate applications with minimal overhead by sharing the host's kernel and resources. This makes them incredibly efficient for modern workloads. On the flip side, VMs virtualize entire operating systems, including the kernel, so each VM running its own operating system, right? They require a hypervisor, adding more overhead, but offering a full isolation, which is a good thing for a security perspective. While containers are ideal for microservices and stateless applications, many companies still rely on VMs, especially for legacy systems that haven't transitioned to the container world. For those cases, VMs remain to go-to choice due to the need for full OS isolation and compatibility with older workloads. The real challenge is that some applications still require the VM model due to dependencies or architecture, but also want to take advantage of benefits of containerization. Koray, what do you think happens in those scenarios?
This is where the KubeVirt comes into play. So why KubeVirt? Why do we need to bring virtualization into Kubernetes? KubeVirt allows you to manage both containers and VMs within a single Kubernetes platform. So instead of managing a separate infrastructure for VMs and containers, KubeVirt provides a way to unify your workloads. This is especially helpful for teams in transition, the ones that are moving from VMs to containers, or for those who want to mix both type of workloads for their flexibility. You can run traditional VM-based applications while modernizing other parts of your stack with containers, and they can run all under the same orchestration layer. But what do you think you can actually do with KubeVirt?
Yeah, that's a good question. First, you can manage VMs just like any other Kubernetes resource, like deployment, pod, services, etc. Meaning that you can scale, restart, and manage VMs using familiar Kubernetes tools. So this allows you to run legacy applications that aren't easily containerized, which is particularly beneficial for organizations needing to support both modern and traditional workloads on a single platform. KubeVirt also supports live migration, which is quite helpful for enabling you to move running VMs between nodes without any downtime. Crucial for maintaining uptime during maintenance. Plus, you can manage the full lifecycle of VMs, provisioning, starting, stopping, and using the standard Kubernetes commands like kubectl, create, kubectl, scale, etc. So yeah, this is lots of virtualization, right?
Exactly. Let's look at how KubeVirt works under the hood. So at its core, KubeVirt is built upon Kubernetes, leveraging its native API for VM management. And that means, as you mentioned before, scheduling, networking, and storage. These are all responsibilities of the underlying Kubernetes cluster. So how it works, there are several key components here. We have the KubeVirt operator, which installs and manages the lifecycle of other KubeVirt components. There is Virt controller, which watches for the VM resources and creates the necessary virtual machine instances, VMIs. There we have Virt launcher. It's a per VM pod that launches and runs the VM workload. So each VM runs inside a pod on a Kubernetes node. Yeah, obviously KubeVirt uses libvirt to handle VM interactions with the hypervisor like Kemu or any other hypervisor. And we have the virt handler. That component runs on each Kubernetes node and it's responsible for handling VM related requests such as the lifecycle operations and migrations. This architecture allows Kubernetes to treat VMs as just another workload alongside the containers. Batuhan, if you can simplify it a little bit.
So yeah, here is the simplified version of the previous diagram by highlighting the key points. The main takeaway is that KubeVirt integrates seamlessly with Kubernetes. In this setup, VMs are treated as pods running on Kubernetes nodes, meaning that they follow the same scheduling and resource management processes as containers. KubeVirt also leverages the Kubernetes API alongside libvirt Kemu, enabling seamless VM lifecycle management, while taking an advantage of Kubernetes features like auto-scaling, networking, and storage. This integration simplifies the process of deploying and managing both VMs and containers within the same environment by eliminating the need for separate tools.
Yes, this brings us to running all of workloads on Kubernetes is quite easy, as our friend Mark says, right? So it's demo time. Before we start, a special thanks to MetalStack Cloud. They provided their bare metal Kubernetes managed service to us to use. So if you want to run KubeVirt on public cloud providers, you have to enable nested virtualization because it's another virtualization layer on top of VMs. So in the case of, for example, AWS, you also have to use metal instance types. Then here we'll be using another bare metal service. And for the demo, we have a repo where we include both Flux and Argo CD installations or scenarios. If you prefer more UI based stuff, you can also try out Argo CD, but today we'll be working with Flux and we'll be creating our VMs on KubeVirt using with GitOps approach. So I have already bootstrapped the Flux in the cluster. Let's check it out. Go get pods and you will see that Flux is already deployed. And now I would like to start deploying first with KubeVirt. So I will be exporting some environment variables. So this one needs to be V version 120 and create a directory for it. And in that directory, I'll be copying the KubeVirt operator and KubeVirt custom resources manifests. If now we take a look, as you see in my GitOps configuration directory, the Flux system is there and there is also another manifest for KubeVirt. Eventually we'll be deploying our VMs using some Helm chart that I just created, which will be handling some other stuff, include creating some SSH keys for the VM. So you can also do such stuff or copy things from here as well. The VM provisioner is app that is used in the Argo CD scenario. You can also take a look at this one. So first I would like to push these things and let Flux create or deploy KubeVirt for us. If I do start checking out. So here Flux first will deploy KubeVirt operator and then it will be responsible for deploying the other components like Virt launcher and Virt handler. Let's wait Flux to do it, or maybe we can just manually trigger the reconciliation on Flux side. Let's try it. Flux reconcile source git flux system. Now if we check the pods, as you see, the virt operator is being deployed, and then it will start deploying the other components to the system when it's up and running. And we can also check status here like this. So as you see, it's being deployed now, and we can also wait for KubeVirt to be deployed. So right now the phase is deploying, and then we'll wait until the KubeVirt part is up and ready. I hope this will be a bit fast. Meanwhile, we can also check again what's happening with the pods, if there are any failures. No, there are no failures. So virt handler, virt operator, controller, a virt API, they're all deployed and it's ready. If again we check for the, yeah, now the condition is met. And if we check all the resources in KubeVirt namespace, yeah, we'll see that virt controller, virt handler, virt API, and operator are deployed. There are a few services. Yeah, also the virt handler is a daemon set, so they're all running. To be able to interact with KubeVirt VMs, you need to install virtctl or virtctl binary or crew plugin to be able to do that. Yeah, I've already installed them, so I will not try those, but essentially you will need them working. As I said, I've already created a Helm chart and pushed it to some OCI repository on GitHub registry. So I'll be using that one to create a VM. First, again, I create a VM there. So I will create virtual machines directory and put all my virtual machine related manifest there. And now I would like to create a source, yeah, from my GitHub registry, and create a source here. And then, yeah, you can check what is created in the values YAML file, but simply I'll be providing a memory for my VM, the host name of my VM, and which container disk will be used. So I'll be using Fedora, and I can also provide some user data like change password, like a password is Fedora, and you can also provide some more information with SSH keys or other stuff. So I'll be creating this values file, and then I will be creating the Helm release. I will use VM chart. The Helm release is test VM1. I'll use this Helm repository that I just created. When I push the code, it will be created. I will create a virtual machines namespace and then use the values file that I also created here. So if we check now, so under virtual machines, I have the KubeVirt VM Helm repo and also one VM YAML to create the VM. So let's again push those to Flux or for Flux to work, and then watch again the pods, what's happening now. So I'm expecting a new namespace here called virtual machines, which will have a pod for my test VM1, hopefully soon, or maybe I can reconcile it again manually. Yes, Flux reconcile. Yeah, so as you see, the virtual machine is being started. So this is a Helm chart. It will first create some SSH keys for me, and then it will start the virt launcher. So virt launcher is working. So this is the pod that contains my VM, and it's being initialized. I think it's running. And if we check the virtual machines, so I have a virtual machine running on that node. It's in running phase, so I think it's ready to be connected. As I said, K8s secrets -n virtual machines. So it created a private and public key for me, this Helm chart. So I will need to download those to connect. So I simply create these two files, public, private key, and then the command to connect to the VM is virt ssh using your identifier. So this is the private key that I just downloaded. I will use the local SSH connection type with Fedora user to test VM1, and it's running on the virtual machines namespace. So if I do that, yes, I accept the key, and then now I am on my Fedora machine. So this is a VM that runs all the stuff. It has its own kernel and everything. uname-a, you will see that it's running my Fedora core kernel and everything. This is a VM, and the good part is that now from this VM I am able to connect to the Kubernetes API. So if I try to connect to Kubernetes.default service or Kubernetes service on the default namespace, yeah, I'm unauthorized, I know that, but I was just able to interact with the Kubernetes namespace. So the application you have running here, whatever that is, it can connect to other services inside your Kubernetes clusters, so that your virtualized application can just connect to your containerized applications. It brings you that information. So some other companies, some companies like Red Hat or Kubernetes, they provide some other approaches to KubeVirt. For example, Kubernetes creates Kubernetes clusters by using KubeVirt VMs. There are VMs on the KubeVirt cluster, and using those VMs, we create a Kubernetes cluster, and you can check that sort of information from the documentation.
To conclude, KubeVirt make it easier to manage hybrid workloads, so you don't have to choose between VMs and containers. With its seamless integration into Kubernetes, KubeVirt opens up new possibilities for legacy modernization and workload consolidation. So thank you for joining our session. You can reach both of if you have any questions. We have both on LinkedIn, X, and also GitHub.
Thank you very much. Have a great conference.